For today's lesson, we're going to be solving for complex numbers in rectangular form using the concept of simultaneous equations. We're going to be simplifying or solving for simultaneous equations of complex numbers in the rectangular form or the standard form. Yes? So we have two forms of complex numbers. The first one being the rectangular form. We also have the polar form. We also have the polar form, which is modulus cis argument, right? But we won't be discussing any equations involving the polar form. So we're going to be strictly focusing on the rectangular form type of simultaneous equations. All right, so the rectangular form, we know that it is made up of two parts. We have the real part and the imaginary part. So the A represents what? The real part, and then the B represents what? The imaginary part. The imaginary part is basically the coefficient of the I. Okay? The I. Now, we say that two complex numbers are equal. Two equal complex numbers are equal and only if the real parts are equal. If and only if the real parts are equal. Which real parts now? If this A and this C are equal. And here's a last one. If the imaginary part or imaginary parts are equal as well. Meaning that the B, of course, along with the sign, if this is equal to this. Okay, so if A is equal to D and the B is equal to D, if this is satisfied, it means that the two complex numbers are equal, right? If these two parts are equal, then the two complex numbers are going to be equal. All right, so this is the fundamental concepts involved in simplifying simultaneous equations with complex numbers. All right, so let's take a few examples where we are solving for x and y for equations involving complex numbers. So here's the first example. Here's our first example. So if you take a look at this example, I have a complex number on the left hand side, but this complex number, where am I writing? Anna? No? Okay, I see. All right. So if you take a look at this equation, we can see that we have a complex number here. Let me back up. Okay. Alright, so the left hand side is 2x minus 3i. The right hand side, this is the left hand side, this is the right hand side. Okay, we have an equal sign between the two sides. So they are basically saying that this complex number on the left hand side is equal to the complex number on the right hand side. But there's a problem. I don't know what x is, I don't know what x is, I don't know what y is. So we have to find the value for x and y. Alright, now the rule for equal complex numbers states that the complex numbers can only be equal if A is equal to C, the B is equal to the D, the real parts are equal and the imaginary parts are equal. So this means that the 2x must be equal to 4. Why? Because the 2x and the 4 are both real parts. So we just make them equal and solve for x. X is equal to 2 for this. And then we're going to solve for y. We're going to take the negative 3, which is the b, right? The b is always the coefficient of the I along with the sign. So negative 3 is equal to a positive y. So we have our answers. X is equal to 2, y is equal to negative 3. Okay, is equal to negative 3. Let's have a second example. Alright, here's example number 2. So for example 2, we have x minus 2, we have x plus 2y minus xi equal to 5i. Okay, what we have on the left hand side is considered a complex number. How do I know? I have a imaginary part, which is this. I also have a, this is b, and then this is a. This is a whole, it's a, right? b is always the coefficient of I. So a, I'm gonna take the x and the 2y and group that together and make it a. And then b is next to I. It's the coefficient of I. Okay, so that happens to be x. Now on the right hand side, if you take a look at the right hand side, you can see that this is also a complex number. However, this complex number doesn't have the a value, which means that the a value is going to be 0. So we're going to rewrite this 5i to a 0 plus 5i. So we have a complex number with a and b right here. Okay, so we have that x plus 2y minus xi. So my a on the right hand side is this, and then this happens to be c, and then this happens to be the d. Okay, so the x plus 2y will be equated to 0, and the minus x, which is this b, is going to be equated to 5. So dividing both sides by minus 1, I get x as negative 5. Now we'll have to go ahead and calculate y. We're going to take the x and substitute it into this equation. Minus 5 plus 2y is equal to 0. Transpose the 5. Then y becomes a 5 over 2. This is x, this is y. Okay, so these are simultaneous equations. You know what, let's take up a bit more challenging problem. Alright, so let's take this as another example. X minus yi is equal to I minus 4 plus 2 plus I over 2 minus I. Okay, now we have a bit of a challenge with this one. The issue here is that we have a fraction. So I cannot have this fraction lying around here. Né? I can't have this fraction lying around here. So I will have to simplify for this fraction before doing anything else, like equating the real parts and the imaginary parts. I cannot do that straight away or right away, right? So I have to simplify for that fraction. How do I do that? I'm going to multiply by the conjugate. This is basics in the topic of complex numbers, right? So I will rationalize or multiply the denominator by its conjugate. So it's basically this multiplied by 2 plus Okay, the conjugate, it's basically this, but instead of having a negative sign between the two values, you're going to have a positive. So this is the conjugate. You're going to multiply by the conjugate on both the numerator and the denominator. So for x minus yi, the left hand side, nothing changes. We can remove this bracket. I don't know why this is here. The bracket was inserted here. Alright, then we're going to FOIL. This 2 times that 2 gives me a 4. This 2 times that I gives me a 2i. This I times this 2, it gives me a 2i. And then this I multiply that I gives me an I squared. Divide by 2 times 2, that's 4. 2 times I, that's 2i. Minus I times 2, that's minus 2i. Minus I times I, that's minus I squared. X minus yi is equal to I minus 4. Plus 4 doesn't have a like term. This 2 and this 2 are like terms. They give me a 4i. And then I squared, that's minus 1. That's minus 1. So that's going to be a minus 1 divided by 4. This cancels this. I'm left with minus I, so it's going to be a minus 1. X minus yi is equal to I minus 4. And then this and this combined, what are they giving us? They're giving us a 3. It's gonna be a plus 3 here, plus 4i. No like terms for the 4i. And then here, this and this combined, when punched on the calculator, they give us what? A 5. They're gonna give us 5. And then simplifying this further, it's gonna be a x minus yi is equal to I minus 4 plus 3 over 5 plus 4 over 5i. Okay, so to simplify for this, I only have one term on the denominator, so I'm allowed to divide by the denominator, divide each term on the numerator by the denominator. Okay, so I'm gonna highlight this and this. I'm simply saying that these are like terms, and then this and this are also what? Like terms. So let's add that. This combined with that 5, it's gonna be 9. It's gonna be 9. It's gonna be a plus 9 over 5 I, and then this and this are like terms. It's I. Okay, I. Alright, then this and this, it's gonna be a minus 17 over 5. Okay, now I have C, D. I have A, B. So this is equal to that. This is equal to that. X is equal to minus 17 over 5. And y is equal to, in fact, negative y. Remember, you also take the sign. So it's negative y equal to a positive 9 over 5. 9 over 5. Then the y is y equal to negative 9 over 5. Solution 1, that's y, and solution number 2, that's x. Okay. Okay, let's take one more example and the last one. Alright, let's grab one more example. Let's take this one. 3 minus 2i, close bracket, minus 6 plus I equal to x plus yi, negative 2 plus 3i. Alright, then you take this and multiply it with that. That's gonna be a minus 18. This 3 times that, it's a plus 3i. This times this, it's a plus 2 times 6, that's 12i. And then this multiplies that one. It's going to be a negative 2i squared equal to this x times that, it's minus 2x. This times that, that's a plus 3xi. This times that, it's minus 2yi. And then this multiplied by that gives us a plus 3yi squared. We're going to have to simplify. We have like terms, that's minus 18 and a plus 15i. And then this, it's going to be a minus 12 minus 1 equal to, I don't see any other like terms, so this is minus 2x plus 3xi. Let's simplify the last one further. Minus 2y I plus 3y minus 1. Alright, so this is minus 18 plus 15i. Negative 12 times this negative 1, it gives us a plus 12 equal to plus 3xi minus 2yi minus 3y. Okay. Then this and this are like terms. Minus 18 plus 12. 12 plus 4, 6. So that's going to be a minus 6. But let me just verify this. Minus 18 plus 12. Yes, negative 6 plus 15i is equal to. Okay. This, I'm going to combine with this. I'm not saying that they are like terms, but I'm just going to group them together. Then this blue and this other blue, I'm going to combine together again, right? There's a reason for that, which I'll provide shortly. Then it's going to be a plus 3x minus 2y. So for the grouped blue terms, there's a common factor of I. We'll have to take it out, right? So for the green, that's minus 2x over here, minus 3y over here, right? So I'm grouping them this side. The reason why I'm taking out the I as a common factor, it's because of I is a common factor anyway, right? But I have to take it out so that I can see the imaginary parts on this equation, okay? So that I can see the imaginary parts on this equation. Now I can clearly identify my A value, which is this 6, my B value, which is the 15, my C value, which is that expression, my D value, which is also that expression. Then we're going to equate A and C, the real parts. So that's going to be a minus 6 equal to minus 2x minus 3y. Let's label this as equation 1. And then we're going to have a positive 15 equal to 3x minus 2y. Label this as equation number 2. Then you're going to solve these two equations simultaneously. So it's up to you, substitution method or the, which one is that one? Or you can use either the elimination method, okay? Or the elimination method. So I'm going to take the first equation and make perhaps x the subject of the formula. So we're going to say minus 6, let's transpose this, about plus y equal to a minus 2x. Then I'm going to divide by minus 2 cancel. X now becomes a minus 6 plus 3y over minus 2. Then we're going to sub x into equation number 2. So this is 15 equal to 3 in bracket. I'm going to substitute the minus 6 plus 3y over minus 2 minus 2y. 15 is equal to, we multiply, so this times that, this times that, that's minus 18 plus 9y over minus 2, minus 2y. Then we simplify again. Now we have a fraction here. We have a fraction. So how do I get rid of the fraction? I multiply by the LCD. Multiplied by minus 2, multiplied by minus 2, multiplied by minus 2. The minus 2 is the LCD for this equation. Minus 2 times 15, that's negative 30, equal to this 2 cancels that 2. I'm left with a minus 18 plus 9y. This times that, it's a plus 4y. Like terms, minus 30, we transpose this 18, it gets to the other side as a positive 18, 13, yeah, 13, 10, yeah, 13y. And then what is negative 30 plus 18? Negative 30 plus 18, that is negative 12. Negative 12 is equal to 13y, and then I divide both sides by y. I get a minus 12 over 13. That's y. And then x we can calculate, of course, using this equation number 3. Alright, I forgot to label it. Alright, so substituting my y into that equation, it's gonna be a minus 6 plus 3 open bracket minus 12 over 13 close bracket over a negative 2. My answer is 57 over 1/3. So this is the final answer, and it concludes our discussion on simultaneous equations involving complex numbers. I hope you enjoyed. If you have any questions, let's talk in the comment section of this recording. For now, I'm gonna catch you on the next one. Bye bye.